Studies on global software competitiveness conducted by the Center for National Software Studies reveal that offshore outsourcing is an asymmetric tactic that delivers a competitive advantage by leveraging low wages and high skills. Managing an arrangement of global participants and functional tasks into an innovation-driven value hierarchy is a maxima-minima problem of pushing the highest skill work to the lowest cost of performance. To obtain these benefits, it is necessary to exercise due diligence in anticipating and avoiding the risks and threats that could occur through the use of the global supply chain. And so the concept of the trusted pipe is born. The trusted pipe architecture, with its intelligent middlemen, can mitigate these risks by reducing friction and assure delivery of the intended benefits. I have a patent pending on the business management and procedures involving intelligent middlemen and the trusted pipe. Offshore outsourcing of computer program software projects is enabled by the convergence of cheap telecommunications, notwithstanding unreliable offshore electric infrastructures, and increasing security concerns. A defined software development lifecycle and roadmap to software process maturity, notwithstanding the limitations of the CMMI. Commoditized programming skills widespread for low-level services, but increasingly available for services higher up the value chain, including R&D. Low wages, notwithstanding the upward pressures now evident. As offshore outsourcing moves to smaller projects, a dependable mechanism is needed to efficiently and effectively manage to scale the initiation of global enterprise projects and their fulfillment by offshore vendors. An offshore outsourcing architecture is needed to reduce complexity and is formed by disassembling and repackaging functions and information flow. The final step in the process is shown here, featuring the global enterprise and offshore vendor. The resulting offshore outsourcing architecture introduces the concept of onshore and offshore control points. The global enterprise control point and the offshore vendor control point perform the heavy lifting using intelligent middlemen. The purpose and role of the control points will become clearer. Managing an arrangement of global participants and functional tasks into an innovation-driven value hierarchy is a maxima-minima problem of pushing the highest skill work to the lowest cost of performance. For computer programming software and information technology projects, the highest value may be assigned the legal and business functions within the initiating global enterprise, and the lowest value may be assigned the engineering function of the fulfilling outsourced vendor. The business need of the global enterprise is met by the engineering solution of the outsourced vendor. Control points, staffed by intelligent middlemen, eliminate friction through process management and culture functions, thereby substantially improving the predictability of the outcome. The sources of friction in outsourcing become a principal concern of the global enterprise, and the need to exercise due diligence becomes an imperative. These issues are the source of outsourcing resistance and span many dimensions, including business and legal, cultural, technical and legal, software engineering, and management. Trusted Pipe features an in-country control point connected by high-speed secure line to an out-country control point with capabilities and protocols organized into 7 layers. These aren't the usual 7 layers. These intelligent layers comprise hard and soft skills spanning ethical dimensions, cultural mediation, intellectual property safeguards, security and privacy safeguards, management and engineering practice, domain knowledge, and technology infrastructure. The trusted pipe architecture is organized to eliminate friction in outsourcing through onshore and offshore control points. The trusted pipe architecture ensures high-fidelity coordination for essential management, engineering, process, business, legal, and cultural aspects. As a result, it avoids conflict, smooths out misunderstandings, and dampens reaction to shortfall. There are two major types of control points. At least one global enterprise control point, GECP, that operates in the United States and manages the network of global enterprises seeking to outsource software development and operations offshore. And at least one outsourced vendor control point, OVCP, that operates in the target country and manages the network of outsourced vendors. These control points are staffed by intelligent middlemen capable of composing and interpreting the multidimensional messages that ensure a harmonious operation. The Global Enterprise Control Point manages the network of global enterprises of buyers, assesses global enterprises and matches buyers and sellers, supports engagement process, training, and measurement, provides oversight and governance of engagements, provides process assurance. The Outsourced Vendor Control Point manages the network of outsourced vendors of sellers, profiles outsourced vendors for leading indicators preferred, establishes due diligence controls, and provides quality assurance. The operations of the global enterprise are specified here as an ETVX diagram. These center on contracting, planning, requirements, change management, and innovation management. The validation focus is on product assurance. The operations of the Global Enterprise Control Point are specified here. These center on process rollout, stakeholder training, change management, risk management, quality management, and culture mediation. The validation focus is on process assurance and management oversight. The operations of the Outsourced Vendor Control Point are specified here. These center on contracting, planning, requirements, change management, project tracking, risk management, and culture mediation. The validation focus is on software quality assurance. The operations of the outsourced vendor are specified here. These center on software product engineering, change management, and innovation management. The validation focus is on software inspections. The global enterprise must have a decision process that incorporates the business value proposition, the strategic versus commodity balancing, and seller financials and risk. The global enterprise must have a demonstrated readiness in strategic software management, software project suite, managing the oversight, and software product engineering. The global enterprise must have a cultural awareness, harmonizing national culture, legal and ethics culture, corporate culture, and process culture. The global enterprise must understand global software competitiveness in terms of controlling the supplier, controlling the customer, controlling competitors, and controlling event threats such as antitrust litigation. The global enterprise must understand and interpret measurements of performance, including product quality, span of control, and frequency of release. The Outsourced Vendor Profile, OVP, assesses factors associated with initial conditions, infrastructure, and experience. Initial condition factors include English language fluency, low wage structure, financial literacy, worker compliance, and privacy and anonymity. Infrastructure factors include software education, software process maturity, access to technology cluster support, telecommunications, legal structure, mutuality and trade, and intellectual property protection and recapture. Experience factors include product offering experience, service offering experience, package application skills, open source experience, and application domain skills. In considering offshore outsourcing, the facts that matter include onshore wages, offshore wages, the workload ratio, and the offshore delta for successive years. Calculating the cost-return ratio begins by calculating the wage-weighted resource metric for the onshore base. The in-house portion of 25% is multiplied by the high-value labor wage of $120 per hour to obtain $3,000. The offshore portion of 75% is multiplied by the low-value labor wage of $60 per hour to obtain $4,500. Together, the onshore base wage weighted resource is $7,500. The in-house portion is similarly calculated as $4,350. The offshore portion is also similarly calculated as $1,950, using the offshore rate to obtain the offshore labor wage. Finally, the cost-return ratio is calculated as 0.16 by substituting the values calculated. The cost-return ratio is the percent of savings achieved by offshore outsourcing and provides the basis for comparing the cost benefits of various options. The cost-return ratios for various options are shown here. Clearly, the more work done offshore, the lower the cost-return ratio. The offshore delta cost of 30% for year 1 also comes into play. In year 2, with some experience, the offshore delta cost is reduced to 15%, and the savings from offshore outsourcing begin to look more attractive. In year 3, the offshore delta cost is reduced to 10%, and the investment in offshore outsourcing is paying off. The cost-return ratio provides the basis for comparing the cost benefits of various options. The cost-return ratio is the proportion of savings achieved by offshore outsourcing. Managing offshore outsourcing financials is all about navigating this table with estimates and actual results. For example, if the year 1 estimate called for a 25-75 mix and a 1/6 offshore wage, the year 1 cost-return ratio estimate would be an attractive 0.29. However, if the actual results turn out to be a 33-67 mix and a 1/3 offshore wage, the year 1 cost-return ratio actual would be 0.11, or a 0.18 shortfall. Actions to increase the cost-return ratio include reducing the offshore delta, improving the onshore-offshore mix, and reducing the offshore wage. If all 3 improvements materialized, the actual result for year 2 would be 25-75 and a 1/16 mix and a 0.40 cost-return ratio. However, perhaps a more likely result would be just 2 improvements and a cost-return ratio of 0.28 or 0.32. Then again, perhaps only 1 improvement materialized with a cost-return ratio of 0.22. The enterprise contemplating outsourcing must attain maturity in global outsourcing. What is global outsourcing maturity? The outsourced vendor must understand the assessment criteria and beyond that must demonstrate compliance with the criteria. What are the criteria for global outsourcing vendor assessment? Without credible cost savings, there is no basis for global sourcing. What is the cost-return ratio and what wage structures work for typical global outsource scenarios? Without a realistic recognition of the risks of global outsourcing, the global outsource engagement cannot succeed. What are the risks for certain country destinations and outsource scenarios? Cost savings versus speed of innovation and security are now the trade-off factors. The cost savings are well understood. As competitiveness pressures increase in a bad economy, the speed of innovation is becoming more of a concern as buyers seek a tighter, more rapid connection with sellers, leading to a return to in-house development and support. As cybersecurity concerns increase, security risks associated with outsourcing are making executives think twice before outsourcing. Here's my contact information. I would be happy to receive questions and have discussions with people on this important subject.